For given any function f, differentiating once is not enough sometimes. So we need to differentiate a function again and again and again. And this process of differentiating a given function again and again is called successive differentiation. And the derivatives obtained are called higher order derivatives. This is called first derivative, obviously, of function f. So this function is y, and first derivative is also denoted by y dash, or simply y subscript 1, or d over dx y, or capital D small y, the function. And this is second derivative, which is also denoted by y double dash, or y subscript 2, or d2 over dx2 y, or capital D2 y. Similarly, suppose this is nth derivative. This is nth derivative. We denote it by y n, or y subscript n, or dn over dxn y, or capital D n y, and so on. Next, we are going to differentiate a function successively for its nth derivative. Let us start off with a simple function. Let's say y equals to e to the power ax. It is exponential function. Obviously, a is constant and variable is x, and we are going to differentiate it with respect to x. Its first derivative is use chain rule. Derivative of exponential function is exponential function itself. So e to the power ax, then the derivative of ax, which is a. Its second derivative is constant, so it will remain as it is. And then the derivative of e to the power x, which is e to the power x, then derivative of x, which is again a. So we will have a square. Its third derivative will be a cube e to the power x, and similarly its nth derivative will be a to the power n e to the power x. Because in first derivative, second derivative, and third derivative we have a to the power n. In third derivative we have a 3, second a 2, 1, 1. So for n we will have a to the power n, and in every derivative we have e to the power x. So by observing the pattern, we have derived the nth derivative of y if y is exponential function e to the power x. Next, let us differentiate, let's say ax plus b to the power m. A and b are constants, obviously, and m is positive integer. M can't be negative or 0. Its first derivative, we shall apply chain rule. M comes out, and this is a power function, like we will treat this one as x to the power m. Derivative of x to the power m is m into x to the power m minus 1. So our x is ax plus b to the power m minus 1. Then derivative of inner function, which is x plus b. Derivative of x plus b is a. Let us rearrange this one. Let us write this one as m times a. Keep the constants one side. Then x plus b to the power m minus 1. Its second derivative will be, these are constants, so m a will remain outside. Derivative of x plus b to the power m minus 1. M minus 1 will come outside, then x plus b to the power m minus 2, then derivative of x plus b, which is a. So it will be a square. let us write this one as m minus 1 a square, then we have x plus b to the power m minus 2. And what will be third order derivative? In third order derivative we will have m times m minus 1, and this m minus 2 will come outside. Then we will get 3 as, so a cube, and x plus b to the power m minus 3, and this will go up to ym, because in mth order derivative we will have ax plus b to the power m minus m, and here we will get m times m minus 1 times m minus 2 up to 1, because in third order derivative we are going up to m minus 2. So in mth order derivative we are going to m minus 1. Third we will subtract 2, second we will subtract 1. So for m we will subtract m minus 1 from m, which is 1. So we will go up to 1. Then a to the power, in first order it is single a, second order a square, third order a cube. For mth order it will be a to the power m. And observe that this one is a constant, because m minus m is 0. So x plus b to the power 0 is 1, and all these terms are constant. So ym is a constant. So m plus 1th derivative will be 0, and the above derivative ym plus 2 will be also 0. So let us derive the pattern here. For nth derivative, clearly if n is bigger than m, n is bigger than m plus 1 or m plus 2 or and so on, our nth derivative will be 0. And if n is less than or equals to m, then our n is 1 among the 1, 2, 3 up to m. And observe, here we are obtaining a to the power, for n we are obtaining n x plus b to the power m minus n, and here we will obtain m factorial over m minus n factorial. See, m factorial over m minus n factorial is what? In numerator we have m times m minus 1, and they will go up to 1. And in denominator we will start from m minus n, and by decreasing, and we will go up to 1. Somewhere here we have m minus n, and up to that the terms are also here, and they are all multiplied. So we will obtain m minus 1. Suppose here is m minus n. These terms will be cancelled, and what is the previous term of m minus n? This is 1 more than m minus n, which is m minus n plus 1, or we can write it as m minus n minus 1. So we are subtracting n minus 1 from m. See, for 3 we are subtracting 3 minus 1 from m. For 2 we are subtracting 2 minus 1, which is 1. So for n we will subtract n minus 1 from m, and this is nothing but m factorial over m minus n factorial. So this is our nth derivative of functions of the form x plus b to the power m. Let us find nth derivative of y, which is sine of x plus b. Obviously a and b are constants. For its first derivative we will apply chain rule. Derivative of sine is cosine x plus b, and derivative of x plus b, b is constant, derivative is 0, x derivative of x is a. So we have a times cos of x plus b. See, for second derivative you may differentiate this one, and for that third derivative you may differentiate a y2, and so on. Then observe some pattern for nth derivative, but we'll be little bit clever here. See, we are going to apply one trigonometry identity. We have sine of theta plus pi over 2 is cos of theta, and we are going to apply this trigonometry identity here. Let us treat this x plus b as theta. So this one is a of sine theta x plus b plus 5 over 2, and for second order derivative we will differentiate this one. A is constant, derivative of sine is cos, and this one will remain as it is. Then derivative of x plus b plus pi over 2. B plus pi over 2 is constant, so its derivative is 0, and derivative of x is a. We already have one a, so this one will be a square. And again we can apply this identity, and this identity says cos of theta is sine of theta plus pi over 2. Let us treat this one as theta. This is a square sine theta, theta is this much, plus pi over 2, plus pi over 2, or we may write it as a square sine x plus b plus 2 pi over 2. Similarly, you can see the pattern here. Its nth derivative will be a to the power n, because in first derivative we have a to the power 1, second derivative square, for third derivative we will have a cube, and so on. For nth derivative we will have a to the power n, and sine x plus b plus n pi over 2. As in first derivative we have single pi over 2, second 2 pi over 2, and so on. For nth order derivative we will have n pi over 2. So this is nth derivative of y if y is sine of ax plus b. And similarly if y equals to cos of x plus b, you can try and you will obtain nth derivative as a to the power n cos of x plus b plus n pi over 2. And for nth derivative of any function, so the procedure is first find first few derivatives, first order derivative, second order derivative, third order derivative, then observe the pattern and derive a formula for nth order derivative of that function. So this is our rule to find nth order derivative of any function. Next, let us solve these two questions. We have to find nth derivative of sine 6x cos 4x. This is our first bit, and second bit is sine to the power 4x. But we are not going to differentiate again and again, then observe the pattern for nth derivative. Here we will apply some trigonometry identity, and we will convert this to functions to terms containing sine of x plus b or cos of x plus b, or sum of terms containing sine of x plus b or cos of x plus b. And this can be done by using trigonometry identity, where we have sine of a times cos of b is sine of a plus b plus sine of a minus b whole divided over 2. So this is 1 over 2. Sine of a is 6x plus 4x, and this is plus sine of 6x minus 4x, and this is half sine of 10x plus sine of 2x and we already know how to find nth derivative of sine 10x and sine 2x. So this is half sine 10x plus half sine 2x. For nth derivative, suppose this is our y, so nth derivative is nth derivative of this one plus nth derivative of this one, because the derivative of sum is sum of its individual derivatives. So nth derivative of this two terms, addition of these two terms, is nth derivative of this term plus this term. So nth derivative of this one, half will come outside. Then nth derivative of sine 10x. We have already found nth derivative of functions with of the form sine x plus b. Here our a is 10 and b is 0. So its nth derivative is a to the power n sine x plus b plus n pi over 2. Here a is 10 to the power n. Then we have sine 10x plus n pi over 2. B is 0. Then nth derivative of this one, half will come outside. Then nth derivative of sine 2x, here a is 2 and b is 0. Then apply nth derivative formula. So we have 2 to the power n sine 2x plus n pi over 2. So this is the nth derivative of sine 6x times cos 4x. Next, for second bit, we are going to convert this one. Let's say this is y to the same form, the terms containing sine of x plus b or cos of x plus b. Note, this one can be expressed as, this one can be written as square, and we already know cos of 2x is cos square x minus sine square x, or this is 1 minus 2 sine square x. So sine square x is take 2 sine square x to this side, so we'll have 1 minus cos 2x over 2. So this is 1 minus cos 2x over 2 whole times square, whole square. Now let us use a minus b whole square. In denominator we will have 2 square, which is 4. So we have 1 over 4. Let us bring this 1 over 4 outside. Then square of 1 minus cos 2x, a minus b square, this is 1 square plus cos square 2x minus 2 times 1 cos 2x, 2 cos 2x. See, we are not done. We have one term cos of x plus b, and this is constant. This will not make any problem. But this term is again cos square 2x. So we will try to reduce this one to some cos of x plus b or sine of x plus b term. Note, from this one we have, this is also 2 cos square x minus 1. So cos square x is 1 plus cos 2x over 2. So cos square x is this one. So cos square 2x is 1 plus cos of 2 times this function, 2 times this variable. For x we have 2x, so for 2x we will have cos of 4x over 2. So this is 1 over 4, 1 plus, in place of cos square 2x, we will write 1 plus cos 4x over 2 minus 2 cos 2x. Let us multiply 1 by 4 in each term. So we have 1 over 4 plus, this is 1 over 8, 1 over 2 times 1 over 4 plus 1 over 8 cos 4x minus 1 over 4 times 2, this is 1 over 2 cos 2x. Note, we have terms containing cos of x plus b, and these are constants, so they will not make any problem for nth derivative. So what is its nth derivative? Nth derivative of 1 over 4, which is 0, because its first derivative is 0, second derivative 0, and so on. For nth derivative we will have 0. Similarly, for nth derivative of 1 over 8, we will obtain 0. For 1 over 8 times cos 4x, 1 over 8 will go outside, and nth derivative of cos 4x, we have nth derivative of cos x plus b, which is n cos of x plus b plus n pi over 2. Here we have 4 as a and b is 0, so this is 1 over 8 and 4 to the power n cos of 4x plus n pi over 2. Next we have 1 over 2. This is also in terms of cos x plus b. 2 to the power n, a is 2 and b is 0, cos of 2x plus n pi over 2. This is our nth derivative, or you may simplify this one further. This is our nth derivative of y. In this way, you can find nth derivative of any given function. You either observe the pattern from first few order derivatives, or you may convert this type of problems to the already known nth derivative of some functions. And for this video, this much. If you want me to find nth derivative of some other function, please let me know in the comment section. Thank you.